All right, step one, XYZ order. Step two is to decide how you're going to label your equations. I just simply label it as 1, 2, and 3. How you label is 100% up to you. Okay? Okay. Step three is to decide which variable are you going to eliminate. Okay? So you're deciding which variable do you want to eliminate. And when we're looking at the variables, we kind of want to make sure that 1, they're friendly numbers. 2, that I can have the combination of a minus plus 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 or plus minus minus. So for example, I may not want to do X, right? Because if I look at X, they all are the same. Do you see that? However, I may want to do Y, because if I look at Y, I have a -2, a +3, and a +1. Yes? Does that make sense? Okay. So I'm going to decide to do Y. Could you have decided to do Z? Yes, 100% totally possible. Okay. You have two options here for evaluating. Option number one is that you can change all of the equations using least common denominator, or you can change it as you solve each piece. Does it make sense? So you either can change LCD in the beginning, the LCM in the beginning, or you can change it each part by part. I'm going to show it with part by part. And the reason why I do part by part is because it keeps my numbers small. Okay. If I do big ones, if I do it as together, my number's going to be a little bit bigger. Okay. All right. So step three, I chose the variable and I'm going to choose my first two equations to work with. I'm going to work with equation number 1 and equation number 2. Does that make sense? Okay. So I'm working with 1 and 2. Working with 1 and 2, I know that I'm going to have to change my 2 and my 3 into a what? Into a 6. 2 and 3 are going to have to become a 6 because the least common multiple between 2 and 3 is 6. So I'm going to have to change each one of these into a 6. Correct? Yes. How can I change 2 into a 6? What am I going to multiply by? Times 3. So I'm multiplying everything in this row times 3. Yes? How am I going to change this into a 6? Times 2. So I'm going to multiply everything in this row times 2. Are you with me? So in row 1, I'm multiplying everything times 3. In row 2, I'm multiplying everything times 2. So here I go. So that gives me 12x minus 6y plus 9z equals 3. Then I have 2x plus 6y minus 8z equals -7. Wait, -7? I didn't say that. -14. What are you talking about? That says -14. It does now. I am going to continue. Ignore y'all bullying me right now. So my y cancels out. And what am I left with? We now add. There we go. 12 plus 2 is 14. 9 minus 8 is 1. And 3 minus 14 is -11. All right. Okay. So that's step 3. Step 4 is to choose 2 other to work with. So on step 4, what are the other 2 I'm going to work with? 1 and 3. So now for 1 and 3, my LCM. So what is the LCM between 2 and 1? 2. So I don't have to change the first one, right? The first one's good to go, but I will need to change the third one. How can I change 1 into a 2? Multiply by 2. I just got to multiply everything in the second one and the third one by 2. The first one's going to stay the same. 4x minus 2y plus 3z equals 1. Remember, that's why we look for that minus plus plus or plus minus minus pattern. So that because the LCM is 2 And since it's already 2, I don't need to change it. The y value that's highlighted. I only am changing the third one. I don't need to change it if it's already the LCM. The first one I did because my LCM was 6, and this isn't a 6. This is a 2. For the first one I did, it can be anything. But on this one, my LCM, my value right here, I'm trying to make these two eliminate, right? And we said the LCM between 2 and 1 is 2. I'm not going to change something that's already 2. So I'm not making any changes to this one on my second equation, on my second system. So no changes are needed. Okay, so making the changes to the continuing. Now I'm going to multiply. So 2 times 3 gives us 6x. And then we have plus 2y plus 4z equals 10.
4.
6. Wait. Oh.
7.
2 times 2 is 4. What are y'all talking?
Oh, it's because I solved it already. My bad.
Excuse me?
I solved it already. I solved it already. My bad.
Yeah, I'm like, guys.
I thought you were already adding it.
We didn't multiply anything on the number 1 equation, right?
Nope. And that's because our LCM is what? Our LCM is 2, and it's already a 2. So we don't change it. All right. What happens to our y's? And we are left with?
That's what I meant.
I wrote my z before my 7. No. 7z equals 11. Yes? All right. Y'all are really concerning me right there. Like, man. Like, 5. So now we're going to decide, are we going to solve by substitution or elimination? What would be the best way to solve this? Substitution. Why substitution? You know what I meant? I really am. The reason why substitution is the better option is because we can easily get z by itself. It has a leading coefficient of 1, right? Do we see that? So what is z? Negative 11 minus 14x. Because it was already negative. Yeah, you can, but that's the long way. You can do elimination. I'm not doing it.
Oh, you got it.
Yes? All right. Right here to get z by itself. All this is going back to what we did for 2 weeks.
Yep.
Nothing different. I have a leading coefficient of 1. So what's the better option to solve? Substitution. Does that make sense? Leading coefficient of 1. Best option, quickest route is substitution. Okay? So I'm going to substitute in for z and solve. So we have 10x plus 7, but instead of z, I'm putting in negative 11 minus 14x equals 11. Okay? Once I'm here, remember the trifecta. Distribute, combine, isolate. Distribute, combine, isolate. Distribute. So we get 10x minus 77 minus 98x equals 11. That's the distribute part. Yes? After we distribute, we then do what? Combine. So we have 10x minus 98. It gives us negative 88, right? So negative 77 minus 88x equals 11. It's negative, so I'm going to do what? We're going to add 77. Now we're down. No, You don't see what's happening here?
It's gonna be a, and then negative, and it's, and then it's negative.
Can someone tell me what x is? -1. X equals -1. Do we see that? So now we have the value of x because we've isolated. So we distribute, combine, isolate. We got the value of x. Now that we have the value of x, can I solve for z? Because I'm going to take the value that I got for x and I'm going to plug it in for z. Yes? So we have z equals -11 minus 14 times -1. Which is -11 plus 14. What's, if you owe me $11 and you have $14 to give me, what are you left with? 3. So z equals z equals 3. Okay? That's it. -14 times -1 is +14. A negative times a negative makes a positive. And then -11 plus 14 is 3. All right. Step 6. Step 6, you choose which one of these equations you want to solve for our last variable. What is, and why am I choosing 3? It's 1y, it's by itself, so do less work. All right, so 3, what is x? -1 plus y, what's z? What's z? 3 equals 5. What's 3 times -1? -3 plus y. What's 2 times 3? What's -3 and 6? So what is y? Y has to be 2. It is a puzzle. Math is just giant puzzles. So what is my solution? X, Y, Z.
2.
Again, mathematically wise, this would be the hardest it would get when you would have to find 2 different LCMs. It's just a lot of work, right? It's not that bad. It's just a lot of work. Okay? Yay?
No, I like this one. It's like, oh, yeah, I'm going.
Okay. All right. So we're gonna, Y plus, what plus 3 equals 5?
Oh. Oh my god,
It happens to the best of us, buddy. You've watched me make tons of questionable situations.